Saturn's rings. Saturn's rings are perhaps the most recognized feature of any world in our solar system. The Cassini spacecraft spent more than a decade examining them more closely than any spacecraft before it. The rings are made mostly of particles of water ice that range in size from smaller than a grain of sand to as large as mountains. The ring system extends up to 282,000 kilometers from the planet, but for all their immense width, the rings are razor thin, about 10 meters thick in most places. Colorful Saturn tilts its darkened ring plane toward Cassini. Against the dark sky, the rings are made visible by the light that scatters through them toward the camera. This natural color view image was obtained on April 13, 2007, at a distance of approximately 1.8 million kilometers from Saturn. This natural color view looks toward the unilluminated side of the rings from about 40 degrees above the ring plane. From on high, the Cassini spacecraft spies a group of 3 ring moons in their travels around Saturn. The images were obtained on February 7, 2008 at a distance of approximately 1.1 million kilometers from Saturn. Surely one of the most gorgeous sights the solar system has to offer, Saturn sits enveloped by the full splendor of its stately rings taken on January 19, 2007. The images in this natural color view were obtained at a distance of approximately 1.23 million kilometers from Saturn. Size of the main rings, with Earth shown for scale. Saturn's most prominent feature, its dazzling ring system, takes center stage in this stunning natural color mosaic which reveals the color and diversity present in this wonder of the solar system. Gaps, gravitational resonances and wave patterns are all present, and the delicate color variations across the system are clearly visible. This view is from Cassini's vantage point beneath the ring plane. The rings are tilted away from Cassini at an angle of about 4 degrees. The natural color mosaic images were taken on December 12, 2004, at a distance of approximately 1.8 million kilometers. The following lifelike movie sequence captures Saturn's rings during a ring plane crossing from Cassini spacecraft's point of view. The movie begins with a view of the sunlit side of the rings. As the spacecraft speeds from south to north, the rings appear to tilt downward and collapse to a thin plane, and then open again to reveal the unilluminated side of the ring plane, where sunlight filters through only dimly. Some moons careen through the field of view during the sequence. The first large one is Enceladus, whose slanted motion from the upper left to center right nicely illustrates the inclination of its orbit with respect to the rings. The second large one, seen in the second half of the movie, is Mimas, going from right to left. Saturn has an extensive system rings, consisting of several individual rings named A, B, C, D, E, F, and G. Rings were named in order of their discovery rather than their position around Saturn. The main or classical rings are A, B, and C, which were known since the 17th century. The others have been discovered only very recently. This diagram highlights a slice of Saturn's largest ring. The ring, red band and inset photo, was discovered by NASA's Spitzer Space Telescope, which detected infrared light, or heat, from the dusty ring material. Spitzer viewed the ring edge-on from its Earth-trailing orbit around the Sun. This diagram illustrates the extent of the largest ring around Saturn, discovered by NASA's Spitzer Space Telescope. The ring is huge, and far from the gas planet and the rest of its majestic rings. Saturn's newest halo is tilted at about 27 degrees from the main ring plane and encompasses the orbit of the moon Phoebe. Both the ring and Phoebe orbit in the opposite direction of Saturn's other rings and most of its moons, including Titan and Iapetus. The bulk of the ring material starts about 6 million kilometers away from the planet and extends outward roughly another 12 million kilometers. The diameter of the ring is equivalent to 300 Saturns lined up side to side. The ring is thick too, it's about 20 times as thick as the diameter of the planet. In fact, the entire volume of the ring is big enough to hold 1 billion Earths. The ring is very tenuous, made up of a sparse collection of ice and dust particles. If you could transport yourself to the ring, you wouldn't even know you were there because the particles are so far apart. There's not a lot of sunlight out at Saturn, so this small density of particles doesn't reflect much visible light. Spitzer was able to spot the band because it sees infrared light, or heat radiation, from objects. Even though the ring material is very cold, it still gives off heat that Spitzer can see.